Okay, this video is about Newton's first law of motion, otherwise known as the law of inertia. First question is, what is a force? A force is described as a push or pull on an object. You should take a tennis ball out of the box in the front of the room and complete the following. I want to drop the tennis ball. I want to roll the tennis ball. Get to know the tennis ball. Give the tennis ball a name. Keep that name for the rest of the period. Here's a good chance to pause the video and then go to question number 1 in the during video questions and answer that. Second question we have to answer is, what is the net force? The net force is the sum of all the forces acting on an object. We figure out that sum by vector addition, which just means we add up the arrows. So it matters which way they're pointing and how big the arrows are. So if the net force is 0, like the example up here, there is no motion. So there's 20 newtons of force pushing this way to the right and 20 newtons pushing to the left. There's not going to be any motion because they cancel each other out. If the net force is not 0, there is motion. So here we have two forces, one pushing 8 newtons to the right and another pushing 6 newtons to the right. Those add together because they're going in the same direction. So it's a total force of 14 newtons to the right. And then that book will move. Newton's first law of motion, as stated, is an object in motion stays in motion, and an object in rest stays at rest, unless it's acted on by an outside force. This is otherwise known as the law of inertia. Inertia is the resistance to a change in motion. So in other words, unless something is pushing or pulling on an object, there will be no change in velocity, which means there's no acceleration. We also have to learn about how to draw a force diagram. So sit your ball on your desk to where it's at rest. It's not moving. There are now two forces acting on it. There's the force of gravity, which affects everything. It pulls everything towards Earth, and that is always straight down towards Earth. Then there's the normal force, which keeps the ball from falling through the table. That's always perpendicular to the table it's sitting on. In this case, since our table is basically parallel with Earth, then the normal force and gravity will look opposite of each other, and they'll cancel each other out. You'll want to pause the video here and answer question number 2 in the during video questions. And if you push your tennis ball with just a very little force, so much that it doesn't actually move, but you are applying a force on it, then there's now 4 forces acting on your ball. There's gravity and the normal force, which we always have. There's also the applied force, which is your push or pull from an outside force, so the little push from your finger. And then now there's also friction, which always is in the opposite direction of the applied force and can exist at different magnitudes. But in this case, if your applied force is so little that it's not actually moving, that means the friction is either the same, it would be the same or greater than the applied force. We'll find out later why it's the same and not greater than. But in this case, all the forces still cancel each other out. Normal force and gravity cancel each other out, and now friction is canceling out your applied force. So there's no motion yet. You'll want to pause the video here and answer question number 3 in the during video questions. And if you push your tennis ball with a little more force, it should move this time. And there's still 4 forces that are acting on it: gravity, normal force, applied force, and friction. But this time, your applied force overcame the force of friction, and now your net force is no longer 0, so the ball moves in the direction that you're pushing it. You want to pause the video here and answer question number 4 in the during video questions. So friction, is it a force or not? Well, it is a force, but it only occurs when an object is experiencing a force. It's often described as a reactive force. So imagine if the ball had no friction at all when rolled across the table. What would happen to it? Well, it would just keep going. There would be nothing to slow it down. If you even barely touched it a little bit to put some force on it, there'd be no friction to hold it back, so it would start moving. So whenever you have a pushing or pulling force and your object is sitting on a table, there'll be some kind of friction, and that's just a reactive force that helps counteract that. At some point, the force becomes too great for the friction, and the friction can't keep up with it, and that's when motion happens. There are three different types of friction. There's the static friction, which just means that you're pushing on it, but nothing's moving. There's sliding friction, to where something slides across the desk or the table, and then there's some friction involved with that. And there's rolling friction, which happens when the object is rolling. So use your tennis ball to observe the three types of friction, and then pause the video and answer questions 5 and 6 in the during video questions.